Let us analyze the situations that are shown here. So this is the mass m1 and this is the mass m2. The distance from the rigid support of mass m1 happens to be x1, and for mass m2 this distance happens to be x2. So this is x1 and this is x2. The mass m1 is connected to the pulley p1 rigidly. So the variation of the distance of the pulley is going to be as per the variation of the distance of the mass m1. So effectively this distance also happens to be x1. Alright, so basically when we are writing down the length of the string is constant, all we need to do is write down x1 plus x1 plus x2 is equal to the length of the string L. On double differentiating this, we get 2a1 plus a2 is equal to 0. For writing down the equations of force dynamics, we get m1g minus 2t is equal to m1 a1. So here I have assumed the direction of acceleration a1 for the mass m1 to be in the downward direction and for the mass m2 also in the downward direction. It is obvious that if tension in this string is T, then tension in this string is 2T because the pulley P1 happens to be massless. For M2, we can write M2G minus T is equal to M2 A2. So these three equations will give us the values of the three unknowns A1, A2 and T on solving them. Here, this is the mass m1 and this is the mass m2. The distance of mass m1 from the rigid support happens to be x1 and the distance of mass m2 from the rigid support happens to be x2. So let us extend the line of the rigid support to understand it better. So here there are two movable pulleys, P1 and P2. P1 and P2 happen to be two movable pulleys. So the distance of pulley P1 from the rigid support will take as xp1 and the distance of pulley P2 from the rigid support will take as xp2. So this happens to be x1, this happens to be xp1, this happens to be xp2 and this happens to be x2. Writing down the equation for the length of string 1, which is L1, to be constant. So this is string 1 and it has length L1. So I can write down x1 plus xp1 is equal to L1. Similarly, I can write down for the string 2, which has a length L2, I can write down x1 minus xp1 plus xp2 minus xp1. I can write down x1 minus xp1 plus xp2 minus xp1. I encourage the student to observe this particular fact, and this happens to be equal to L2. So x1 minus xp1 is this much part of the length of the string and xp2 minus xp1 is this much part of the length of the string. Note that we have in earlier questions we have taken the pi r length of the string that goes over here as well. It gets differentiated down to be 0 when we are going to differentiate these equations. That's why we are not taking the same as of now. Now for the string 3, this is the string 3 with its length being L3. So the length of the string 3 happens to be x1 minus xp2. So this is x1 minus xp2 plus x2 minus xp2 equal to length of string 3 L3. So on differentiating these equations, we get, on differentiating this one, the first equation, we get a1, double differentiating, a1 plus ap1 equal to 0. From the second equation, we happen to get a1 plus ap2 plus minus of 2 times xp1 equal to 0. From the third equation on differentiation, we get a1 plus a2 minus 2 times, okay, so this is ap1, it's minus of 2 times ap1 on double differentiating. From the third equation, we get a1 plus a2 minus 2 times ap2 equal to 0. So these are the three equations. We need to eliminate ap1 and ap2 from these three equations in order to get the relationship between the accelerations of a1 and a2. So ap1 happens to be minus of a1 from this equation. ap1 happens to be minus of a1. So if we substitute that in this particular equation, then we get three times a1, because this term will become 2 times a1. So 3 times a1 plus ap2 equal to 0. This is what we'll get, and hence ap2 will be minus 3 times a1, and minus 2 times ap2 over here will turn out to be minus 6 times a1. For ap2 we have to include the equation 3a1 plus ap2 equal to 0. So on substituting, ultimately the minus minus sign will get cancelled out. I'll do it over here. So this is a1 plus a2 minus 2 times ap2 happens to be minus 3 times a1. This equal to 0. So basically 6 times a1 plus a1. So you'll get the constraint motion equation ultimately to be, so this is the equation. It is 7 times a1 plus a2 equal to 0. So this is the equation that will give us the relationship between the accelerations of mass m1 and m2. Now for the Newtonian force dynamic equations, we can write down. So for that, let's understand the tension in the string. Let us say this is T. So this is T. So this happens to be 2T, and then this is 2T. This happens to be 4T, and then this is 4T. So we can write down the equation m1g minus 7T is equal to m1 a1. So a1 has been assumed to be in the downward direction, and m2g minus t is equal to m2 a2. Yeah, so these are the three equations that will give you the solution for the constrained motion system that is shown over here. Now next question has three masses, m1, m2 and m3. It's a pretty straightforward question. So this is the distance x1, the distance is x1. So these two distances happen to be x1, these two, because that pulley is moving as m1 mass is moving. So I can write down this distance, these two distances to be effectively x1. Okay, the next two distances are x2. So this and this, because the second pulley P2 is connected rigidly to the mass m2. So this is pulley P1, this is pulley P2. So these two blue distances are nothing but x2. And the third distance, this distance happens to be x3. So this distance is x3. So I can write down this is x1, this is x1, this is x2, this is x2 and this is x3, because x1 is varying with the mass m1, x2 is rigidly connected to the pulley P2 which is rigidly connected to the mass m2 and it is varying as the mass m2 is moving. x3 is connected to the mass m3. So we can write down the equation for the length of the string to be constant, and we would get 2 times x1 plus 2 times x2 plus x3 is equal to length of the string, which happens to be constant. On double differentiating this equation, we get 2 times a1 plus 2 times a2 plus a3 equal to 0. So this is our first equation. For the mass m1, we are assuming the acceleration to be in the downward direction a1. Here the acceleration for mass m2 is a2 in the downward direction, and for the mass m3 it's a3 in the downward direction. So basically the tension in the string is T because it is one and the same string. So for the mass m1, 2T will be the tension acting in the upward direction. So m1g minus 2T is equal to m1a1. For m2 we can write m2g minus 2T is equal to m2a2. And for m3 we can write m3g minus T is equal to m3a3. So these are the equations which will give us the constraint motion relationship as well as the Newtonian force dynamical equations, which will give us the solution to the given set of question, to the given particular question. So this is the mass m1 in this case, and this is the mass m2. So the accelerations, I'll assume the acceleration of mass m1 to be a1 in the downward direction and a2 for the mass m2. The distances are so measured. This happens to be x1. This pulley is also connected to the mass m1. So this distance also happens to be x1. This distance also happens to be x1. See, the difference in distances x1 over here, this part, okay, is constant. So whether I take it or not is immaterial, because even if I had taken it, then it gets differentiated out to be 0. Similarly, the same thing happens over here. So basically this length is varying as x1 is varying, this length is varying as x1 is varying, and this length is also varying as x1 is varying. So this is x2 over here. So this much part is basically x2. This part is essentially x2. So we can write down this varies as x1, this varies as x1, and this varies as x1 as well, and this part varies as x2. So basically, in order to figure out and write down the length of the string, you can see that this is x1, 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 and the final part is x2. So basically we have to write down x1 plus x1 plus x1 plus x2 is equal to the length of the string. So 3 times x1 plus x2 is equal to the length of the string L. On double differentiating, we get 3a1 plus a2 happens to be equal to 0. So this is one equation. The other two equations are Newtonian force dynamical equations. So for the mass m1, we can write m1g minus, okay, so let us say this tension is T, T, T and T. We can see that 3T is effectively acting upwards on the mass m1. m1g minus 3T is equal to m1 a1. So this is the equation for the mass m1. And for the mass m2, we can write m2g minus T is equal to m2 a2. So this is for the mass m2. So these are the three equations which will help us solve this particular case using constrained motion and Newtonian force dynamical equations as well.